Hey, what's going on? It's Justin Dickmeyer from engineeringtrainingexam.com, and in this video we will review linear regression. It may be necessary at some point to draw a straight line through a set of data points. Using the method of squares, we can define the least squares regression line that best represents the given data. The regression line is given by y is equal to mx plus b, and the characteristics of this line can be defined using a four-step process. So we're using the method of squares to find the least squares regression line. Y is equal to mx plus b. Now when we're using the method of squares, we're given a bunch of data points. Say x1, y1, x2, y2. We have a bunch of data points on a graph all over the place, and we want to define a best fit line y equals mx plus b. So to do that, we need to do four steps. Number one, we need to set up a table with all the data points. So we got x1, y1, and we have all of our data points going down. Next thing we need to do, in another column, we need to square all the x data points and put the answers here. We need to square all the y data points and put our answers here. And then we need to take our x and y data points and multiply them by each other, and then put those values in some column. And then at the bottom of the table, what we need to do is sum. So we'll have just the summation, and we'll sum all the values in column 1. So this all the sums of the x values, all the sums of the y values, all the sums of the x values squared, all the sums of the y values squared, and the sum of all the x, y terms. After that, we have 1, 2, 3, 4, 5 points of data, new data that we will use to define our method or our least squares regression line. We also need to determine the value of the sum of the x terms squared. So we need sum of x squared. Now these aren't the sum of the x terms squared in this column. This is actually the sum of the x's squared, and we need the sum of the y's squared as well. So here are two more values. And then finally we just need the means. So that's step number one. We need to find all those values. So in review, it's sum of x's, sum of y's, sum of the x squares, sum of the y squares, sum of the x's squared, sum of the y's squared, the means, and finally the sum of the x times y. So I do this all in a table, and we come up with this 1, 2, 3, 4, 5, 6, 7, 8, 9 new data characteristics of all the data points. So that's step number one. Once we have all that information determined, we can go on to step number two, and that's to calculate the slope of the line. And the given equation to define the slope is n times the sum of the x, y points. And this is all the information that we got from step number one, and we just plug it into this information. So we got n times the sum of the x times y points minus the sum of the x points times the sum of the y points divided by n times the sum of the x points squared minus the sum of the x points squared. So that's step number two. Step number three, we need to determine the y-intercept, and that's done simply by just rearranging y is equal to mx plus b and using the mean values. So we got b which is the y-intercept, is equal to the mean minus m, which we just defined in step 2, times the mean x. So we got the mean, and once again these values were all determined in step number 1. And then finally, step number 4, we need to determine the goodness of the fit by calculating the correlation coefficient R. So this is a pretty lengthy equation, so I'll just write it out here. We got n times the sum of the x times y values minus the sum of the x values times the sum of the y values divided by the square root, and this is a long square root line, n times the sum of the squared x values minus the sum of the x values squared times n times the sum of the y values squared, the squared y values, minus the sum of the y values squared. So that's the goodness of fit, and that's called the correlation coefficient R. Now if R exceeds 0.85, then the fit of this line to that data is considered to be good. So we want our R to be greater than 0.85. If it's less than 0.85, then we can probably consider that fit poor. And if R is equal to 1, then the fit is perfect. So let's run through an example of how we would do this 4-step process using given data points. So let's say we have an example here. So let's say that last year 5 randomly selected students took a weed-out exam before they began a certain engineering course. The engineering department wanted to establish the following information. Number 1, they wanted to know what the linear regression equation would best predict statistical performance based on the weed-out scores. So in essence, they wanted to define a least regression line that fit the 5 data points. So step number 1 is find a linear regression line y is equal to mx plus b based off the 5 data points that they were given. The second step is the university wanted to know if some future student scored an 80 on the weed-out exam test, what grade would they expect them to make in their engineering course. So in essence, they want to use this linear regression line to plug in a value for a student taking a certain exam so they can guess or predict what that student would do once they got into their engineering class. So use the equation to determine or predict future score. That's going to be our second step, our second question we want to answer. And finally, the third question they had was, how well does the regression equation fit the data? So they want to know what's the R coefficient? How good is the fit of their line to the data from the 5 data points that they have to establish this line? So let's say that they were given this information in a sort like this. So there's 5 students, 1, 2, 3, 4, 5, and they took a weed-out exam, and in that weed-out exam, student 1 scored a 95, student 2 at 85, student 3 an 80, student 4 70, and student 5 a 60. And so after they took that exam, they went in and did their engineering class, and the scores were were this. Student 1 got an 85, student 2 got a 95, student 3 got a 70, student 4 a 65, student 5 a 70. So now we have our 5 statistical points, x, y points. So the first step is to take all the x values and square them, and we get 90, 25, 72, 25, 6400, 4900, and 3600. We now take our y values and square them. We get 72, 25, 90, 25, 4900, 42, 25, and 4900. And finally, we do x times y. So in this column, we're going to get 95 times 85 is 8075, 8075, 5600, 4550, and 4200. So there's our table started there. Now we need to find the sum of all these columns. So the sum of the x values is 390, sum of the y values is 385, sum of the x1 squared or x squared values is 31,150. Sum of the y squared values is 30,275, and the sum of the x times y value is 30,500. Finally, we need x bar and y bar, which is simply just adding and dividing by 5, and x bar is going to be, or the mean is going to be 78, and the y mean is 77. And now finally, just taking these two values over here, we got this, sorry, we take these values. So we got 31,150 squared is 152,100, and then y value squared is 148,225. Alright, so let's start a new page here, but we'll write down all of the values that we just figured out. So we had the sum of the x terms was 390, sum of the y terms 385, and then sum of the x squared terms is 31,150, sum of the y squareds 30,275, sum of xy was 30,500, and then we got x bar 78, y bar 77, and we got sum of the x values squared is equal to 152,100, and sum of the y values squared 148,225. Alright, so there's all of our defined data points. Now all we need to do is take those and plug them into our equations and to determine the line and all the information that the school wants to know. So once again, we're looking for a linear regression line. Y is mx plus b, so we need to determine m, and plugging this into the equation that we previously defined, we got 5 times 30,500 minus 390 minus 385 divided by 5 times 31,150 minus 152,100, and we got the slope 0.64. So that's step 2. Step number 3 is to determine the y-intercept. Once again is b y bar minus mx bar, which is equal to y bar is 77 minus 0.64 times 78, and we got the y-intercept to be 27. Therefore, we can now define our line as y is equal to 0.64x plus 27. So this answers their first question. What linear regression equation best predicts statistics performance based on the weed out score? So if we are given the 5 data points, the engineering department was given the 5 data points, they can fit a line given by 0.64x plus 27 to that data. Now the next question was, if a student made an 80 on the weed out exam, what grade would they expect them to make in their engineering course? So if they made an 80 on their weed out exam, which is our x values, what would the y value be? And all we need to do now is just plug that into the equation. Y is equal to 0.64 times 80 plus 27, which is equal to 78.2. So if a student scored an 80 on the weed out exam, you can expect him or project that he would score somewhere around 78.2 in the engineering courses. Now finally they need to determine, okay, well we see that we have a good correlation here. Is the data that, or is the projection a good projection given the linear regression line? And to figure that out, we need to define R, which is once again our correlation coefficient. So plugging in the data, once again, all this data that we were given up here into that definition that we previously defined, we got 5 times 30,500 minus 390 times 385 divided by the square root, once again, real long square root of 5 times 31,150 minus 152,100 times 5 times 3275 minus 148,225. So that's all under the square root. Now throwing this long equation into the, or all this data into the calculator, we find that R is equal to 0.693. Now if you recall, we wanted our R value to be greater than 0.85. If it's greater than 0.85, then we can consider our line a good fit, but it's not in this case. Therefore, it's probably not good, or probably not useful for the university to predict future scores based off the data that they were given. And this is probably just because they used only 5 data points, and that's probably what you could expect if you tried to base anything off 5 data points. So anyways, that's all I got for you guys today. Go ahead and head on over to engineeringtrainingexam.com and sign up for my free EIT preparation bootcamp, or shoot me some suggestions or feedback. I'd love to know how I'm doing, if I'm helping you guys out prepare for the exam. That's what I'm here to do. So if you guys have any questions, just let me know. All right, take care. Bye.